Hello everyone, and welcome to this in-depth video presentation for Continuous Assessment 3. I am Raj Patel and my topic is Unit 4, the network layer. Over the next few minutes, we will thoroughly explore the networking fundamentals, protocols, and complex routing mechanisms that make global data communication possible. So now, what is the network layer? The network layer is the layer 3 of the OSI model. Its role is to manage data delivery between a source and a destination across multiple or interconnected networks. It achieves this through two essential functions. First, logical addressing. These provide unique identifiers for device across its different networks using IP addresses. This acts as a device home address, allowing it to be located anywhere on the internet. Second is routing and path selection. This process determines the best route or the most efficient path for data packages to travel from the source to the destination. The main goal is to find the most efficient path across all the interconnected networks. So now, why is network layer important? The network layer is the foundation of modern digital life. It enables global connectivity. It divides large amount of data into smaller packages and then efficiently route through packages across the world. This also ensures reliable communication and essential error reporting. It also handles device discovery. Without logical addressing, devices could not find each other. By providing logical addressing using IP addresses, it makes the internet as we know it's possible. So now at the network layer, we use two fundamental methods for packet switching. First one is a virtual circuit, second one is a datagram network. So now let's find out what's the difference between them. The first one is the connection type. The virtual circuit is connection oriented. This is like setting up a dedicated path, whereas a datagram network is a connectionless. This treats every packet independently. The second difference is path selection. The virtual circuit is a fixed path established before data transfer begins, whereas a datagram network uses a dynamic path per packet. Third one is the reliability. In virtual circuit, reliable delivery is assured, whereas in datagram network, packet may vary out of order or take different routes. The fourth one is the example. For the virtual circuit, the example is like a telephone network, whereas for a datagram network, it's like the internet or the IP or you can say the UDP. The fifth one is the overhead. The virtual circuit may cost higher setup cost because resources are reserved, whereas the datagram network has a lower per packet cost because there is no initial setup fees. So our next topic is Internet Protocol. The Internet Protocol or the IP is the backbone of the datagram network. It is the fundamental protocol responsible for addressing and routing data packages across network worldwide with reliability and efficiency. The core mechanism is the unique IP address. Each device receives one which acts like a digital home address that enables precise identification and data delivery. Moving next, let's talk about the IPv4 addressing system. The IPv4 is the version we are most familiar with. Now let's talk about the structure of IPv4. It uses a 32-bit addressing system represented by a dotted decimal notation. A typical format is like 192.168.0.1. Now let's talk about the component of the IPv4. The address is divided into two parts. The first one is the network part, which is used to identify the network. The second part is the host part, which is used to identify the individual devices. Now let's talk about the limitation of IPv4. The main drawback is the finite address space, which is currently causing a shortage worldwide. This, along with complex configuration and limited scalability, draw the need for the next version. So now, due to several limitation of IPv4, we need a new generation IP, which is a IPv6, which is a necessary successor. So you might be thinking why? So let's discuss point wise. The first one is the massive address space. It uses a 128-bit addressing, providing a virtual unlimited address space for future internet growth and device connectivity. The second point is about the format. The address are represented as hexadecimal groups separated by colon as you can see in the example here. The third point is the enhanced feature. The IPv6 introduced several benefits including improved routing efficiency, enhanced security with built-in encryption support, and better quality of services management for real-time application. Now let's move on to ICMP, which is Internet Control Message Protocol. Since IP is connectionless, it lacks built-in error handling and relies on ICMP for vital control and error message. The first one is error reporting. ICMP is primarily used for error reporting. It enables network devices like a router to send error and status messages. For example, a Type 3 destination unreachable message tells the sender if if a service is unavailable or a host could not be reached. The second one is the diagnostic tools. ICMP is essential for network maintenance and diagnostic. The first one is the ping. This common utility measures connectivity and latency. It relies on ICMP, which is your echo request type 8 and expect an echo reply type 0 message. The second is the trace route. This utility uses ICMP to map the path taken by packet between two devices, which is critical for network troubleshooting. The third one is the message type. ICMP messages are defined by the 8-bit type field, which provides a description of the message. Some other critical types include type to leave TTL field drops to zero in transit, cause the packet to be destroyed. Now we move on to the final and arguably most critical function, routing. The first is path determination. Routing is the process of determining the optimal path packets take to reach the destination. The second is algorithm computation. This path determination relies on routing algorithm. These algorithms use mathematical models and network topology data to compute the shortest or the most efficient path. The two main type of routing algorithms are linked-state routing and the distance vector routing. These tables summarize how the two routing algorithm types differ. First, the distance vector uses hop count as a primary metric, whereas the link state uses network topology as the basis. RIP is an example of the distance vector, whereas OSPF is an example of the link state. In distance vector, updates are sent periodically to the neighbors, whereas in link state, updates are sent to all the routers only when changes occur. In distance vector, network knowledge is limited to neighbor or the local view, whereas in the link state, network knowledge has complete topology knowledge, or we can say the global view. The convergence speed for the distance vector is slow, whereas for the link state is faster. So our next topic is routing information protocol. So it is a classic example of distance vector protocol. The characteristics of routing information protocol are it uses hop count as a primary metric. A router typically sends its full routing table to its neighbor every 30 seconds. So there are some limitations of the routing information protocol. So it has limited scalability because its maximum path is restricted to only 15 hops. Paths with more than 15 hops are considered unreachable. Furthermore, its periodic updates consume bandwidth and its slow convergence can cause issues like routing loops. So the next is open shortest path first. This is a key example of a linked routing protocol, typically used to find the best path between routers switching an autonomous system. So let me tell you how it works. The first is LSA mechanism. OSPF router uses link state advertisement to share complete topology information across the network. This allows every router to build a full informed map for the routing decision. Second, how does it calculate? To find the optimal route, OSPF uses digest the shortest path first algorithm. This algorithm mathematically computes the best path based on the network cost and distances. The third is the design. So OSPF is highly scalable and is often uses a hierarchical design such as the OSPF Area 0 backbone. So now our final routing protocol is BGP, Border Gateway Protocol. This protocol is crucial because it is the only one that literally connects the global internet. The first is the inter-domain routing. BGP handles inter-domain routing, meaning its job is to connect different autonomous systems across the internet infrastructure. It is used primarily by ISPs and backbone providers. The second is the global path selection. BGP finds the best inter-domain route globally using a path vector protocol methodology. This selection is based on complex policy-based routing decisions to ensure stable and efficient internet connectivity. To conclude, here are the key takeaways or the summary from the Unit 4, the network layer. The network layer function. It successfully handled addressing and routing, managing data delivery between source and destination across multiple networks. The IP protocol capabilities. The Internet Protocol, with its unit address schemes IPv4 and IPv6, enable logical communication and provides the foundation for modern Internet connectivity. ICMP error reporting. The Internet Control Message Protocol reports errors and aids diagnostics like ping, providing essential network troubleshooting capabilities. Routing algorithm efficiency. Routing algorithm like RIP, OSPF, and BGP ensures data find optimal paths, making internet communication reliable and efficient across global networks. To support this presentation, I use primary course material including the Unit 4 PPT notes, and for the deeper understanding, I utilize online resources and documentation such as tutorial points and Geeksocket, as well as Cisco official documentation and RFC document. Thank you everyone for watching my CAT video presentation. I hope this provide a clear understanding about the network layer. Thank you.